All right, it says we're recording. All right, so we're going to move on to section 10. We're going to spend 2 days on this section. And stupid messages. And ta-ta to you too. Okay, so section 10, day 1. I'm just going to start by doing an example. What we're going to do is they're going to give us some sinusoidal function. Evaluation of inverse relations. All right, so they're going to be giving us some sinusoidal function like this in terms of y, and the directions will say, first of all, to transform the equation so that theta is in terms of y. So we want to transform this equation so that theta is in terms of y, and so what they're wanting us to do is to solve this equation for theta equals blah, blah, blah. All right, so we want to get theta all by itself. All right, so here's what we're going to do. We're going to take this one step at a time. The first thing you can do is add the constant over, add 1 to both sides of the equation. So I'll do that first, and I'll have a y plus 1 is equal to 12 cosine of 3 times theta minus 10 degrees. I'm going to cross that out because I took care of that one. We're doing reverse order of operations here, right? So next thing you can do is I can divide both sides of the equation by 12 so that I'll have a y plus 1 divided by 12 is equal to cosine of 3 times theta minus 10 degrees. So now I've gotten rid of the 12 in the original problem. The next thing I can do is get rid of this cosine. Yeah. And so in order to get rid of cosine, what undoes cosine is inverse cosine. So I'm going to take the inverse cosine of both sides of this equation. So you'll write inverse cosine of the left-hand side is equal to, when you do inverse cosine of cosine, you're left with this argument is what it's called. It's the part right after cosine. So you'll have 3 times theta minus 10 degrees. All right. Next thing, I got rid of cosine. I'm going to cross it out. Yay. All right, next thing I can do is get rid of this 3 by dividing both sides by 3. Instead of writing all of this craziness divided by 3, I'm going to multiply by 1/3. Multiplying by the reciprocal, same as dividing, right? Reciprocal 3 is 1/3. So I've got 1/3 times inverse cosine of y plus 1 over 12 would be equal to, and now you're left with the inside the parentheses, theta minus 10 degrees. I got rid of the 3. And the last part that you need to do is get rid of the minus 10 degrees from the right-hand side. So I'll just add 10 degrees to both sides of the equation, and I will get 1/3 inverse cosine of y plus 1 divided by 12 plus 10 degrees is equal to theta. I have now rewritten the equation that had y equals blah, blah, blah. I now have theta equals blah, blah, blah. That is your answer. I'm going to go back up here and cross out the minus 10 degrees just to show that, okay, I took care of everything. I got everything over to the other side. So that's part A. In the book, it's going to ask you next, part B, to find the first positive value of theta for which y is 5. What I'm going to do is I'm going to do part C first because I think it'll make more sense. Part C, what we're going to do is sketch the graph of the given function. So not the one we just found, but we're going to graph the given function, the one that they gave us, the original one, to show that the answer to part B is reasonable. And obviously we have not done part B yet, but I'm going to do part C first, and then we'll have the graph all ready to look at, right? So keep in mind the given function, this guy, we're talking about the original one that was given to us, right? So the one that was given to us was y equals, the -1 was in front, but remember that's the d, and we always had you move it to the end of the equation. So 12 cosine of 3 times theta minus 10 degrees minus 1. I just rewrote them. Instead of -1 plus the 12, I brought it over to this side, so that way you can see that this is going to be your A, that'll be your B, this will be C, and then D when you're identifying how to graph it. Yeah. All right, so we're going to graph this equation. What a nice review of the first half of the chapter, right? When you had to graph it. So here my A is 12. B is the number in front of these parentheses in front of there. So B is 3. C, remember it's theta minus C. So it's a positive 10 degrees. If you had seen a plus 10, it would be a negative 10 degrees. But it's always theta minus C. You take the opposite sign of what's inside the parentheses. The D is exactly what you see, right? It's I see a -1. I don't take the opposite and sign. It really is a -1. The period is what we found next. This is theta, and you see degrees here. That should help you out too. But that means that we're going to do this in degrees. The period will be 360 degrees divided by B. And our B was 3, so 360 degrees divided by 3 gives you 120 degrees is going to be the period. And then, remember, we found what we call the increment length, which is the length in between each of the little tick marks. And we take the period and divide it by 4. So 120 degrees divided by 4 will give you 30 degrees. Now, all right, before I draw my axis, what do I need? I need to go up to 12 and down to -12, but then shifting it down also. All right. Hopefully that's enough room. All right, I'm going to do 2 bookends, cut it in half, cut it in half, cut it in half. So I've got 5 tick marks with 4 spaces in between them. C is going to be your first tick mark, 10 degrees. You're going to add the increment length to get the next one. So 10 degrees plus 30 degrees would give you 40 degrees. Plus 30 degrees will give you 70 degrees. Plus 30 degrees will give you 100 degrees. And then plus 30 is 130. Let's check that period. Make sure my tick marks are right by taking the most right point, subtracting from it the most left point. So 130 minus 10 gives you 120. Yep, check. Our period is correct. All right, where is the y-axis? Well, positive 10, so it's to the left, and not quite as big as that, but that. I'm going to put a little X through it to remind myself I'm not going to put one of my tick marks on the y-axis, not for just my one period of cosine. I need 12 units up. All right, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 6, 7, 8, 9. Just labeling a few more just for reference. You need to go down the same amount. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And then your cosine graph starts at, it's a positive a value. Right, so we're going to start up high. So when your theta is 10 degrees, I'm going to do this in, am I going to do it in 2 steps? You know, are you guys okay with? It would be up to 12 and down to negative 12, but then we're going to shift the whole thing down 1 unit. So what you could do, and what, if any of you have tutors, maybe some of them taught you this, you could draw a new -1 x-axis. So there's your middle, and from here, right, that's -1, you're going to go up 12 so that it'll be to 11. Your middle will be at -1, and then you need another down 1 for -13. Yeah. So that at 10 degrees, you're actually at 11 because it would have been 12, but you're shifting down 1. At 40 degrees, you would have been at 0, but then you're shifting down 1, so there's a point. At 70 degrees, you would have been at -12, but then you're shifting down 1, so it's at -13. At 100 degrees, you would have been back at 0, but we had shifted down 1, so it's at -1. And then at 130 degrees, you're back up top, which was 12. We shifted down 1, so now it's 11. So here's my graph of 1 period of this cosine graph. All right. Now, technically, it keeps on going in both directions, right? So this is just 1 period, right? But technically, this thing keeps on coming back down, right? And it goes down to here, and it keeps on going. And same thing here, is this one keeps on going. Yeah, so this graph technically keeps on going in both directions. Keep that in mind for tomorrow when we're going to find a whole bunch of values. And it's because this graph goes on forever and ever in both directions. And so, yeah. All right, so now that we got our graph, which was part C, right? Part B is going to ask you to find, I'm going to change the directions. It says the first positive value. We're going to do more like that tomorrow. I'm going to just say, let's find one value of theta for which y is equal to 5. All right, we're going to do it algebraically. And from part A, we had, not part A, from part A, we had that theta was equal to 1/3 inverse cosine of y plus 1 over 12 plus 10 degrees. That's what we had figured out from part A. So now, if I want to find a value for theta when y is 5, I'm going to plug a 5 into y. So when y equals 5, what do I have? I would have theta equals 1/3 inverse cosine of, I'm going to plug a 5 into y, plus 10 degrees. And then we solve for theta. No? So this means that you've got 1/3 times inverse cosine of 6/12, which is 1/2. Now, okay, you know this. Inverse cosine, yeah, of 1/2. Because remember, from the first part of the chapter, if you had theta was equal to inverse cosine of 1/2, it was the same thing as saying cosine of theta is 1/2. And if cosine of theta is 1/2, that's your x value, which means your height was read 3/2, right? And what angle had a cosine of 1/2? At 60 degrees. It was the tall triangle. So that means that this little square box right here, the inverse cosine of 1/2, that's equivalent to 60 degrees. So this is 1/3 times 60 degrees, and then plus 10 degrees. 1/3 times 60 degrees would be 20 degrees, and we still are going to add 10. And so one value of theta for when y is 5, it's 30 degrees. More than that, though, there's actually an infinite amount of answers where when y is 5, you've got a whole bunch of angles where that happens. And so that's why they had you do part C, where they wanted you to graph it, right? And so now I'm going to scroll up to part C, but keep in mind, we came up that with when your theta is 30 degrees, that your y value is 5. So I'm going to scoot it up to the graph, and part C wanted us to see if our answer was reasonable, right? So let's look at where is y equal to 5. So here's when y is 5, right there. So if I were to draw, I'm just going to draw a vertical line going through this thing. Do you see that there's an infinite amount of when y is 5? You've got it here, and here, and here, and here, and here, and it would keep on going. There's a whole bunch of angles where y is 5. And if you see, here's the point on the graph when y is 5, and if you were to go straight down, is it reasonable that right here is 30 degrees? Sure enough. Sure seems reasonable to me. Yeah. So we found it algebraically, but we confirmed it with the graph. And tomorrow we'll end up finding like all of these angles. Well, we won't find all of them, but we'll find more than one anyway, of where your y is 5. All right. Hopefully that made sense. We'll do another one just in case, but 30 degrees is just one of the values when your y value is 5 for that equation. Okay, let's look at another example. Y equals -2 plus 8 times sine of 2 pi over 3 times x minus 1. Okay, so part A is going to be solve for x. We want x equals, and then oh gosh, sorry. Partners are here. This is what happens when we work from home. I can't keep everybody quiet. I've tried. It hasn't worked. Okay. All right, so we're going to solve for when x equals everything else. So first step, add the 2 over. And so I've gotten rid of the 2 there, took care of that one. Next step, divide by 8. And then you would be left with sine of 2 pi over 3 times x minus 1. Next step, take inverse sine of both sides. And that undoes this sign so that you're left with just 2 pi over 3 times the quantity x minus 1. Pi sign. Ta-ta. Next step, get rid of the 2 pi over 3. So you would divide by 2 pi over 3, but ew, who wants to do that? Instead, I'm going to multiply by the reciprocal. The reciprocal of 2 pi over 3 would be 3 over 2 pi times inverse sine of 1 plus 2 over 8. And then you're left with just the parentheses, the x minus 1. And the last step, so that we can solve for sine, it would just be adding the 1 over. So you get 3 over 2 pi times inverse sine of y plus 2 over 8 plus 1 is equal to x. Yeah? Perfect. Okay, I want you to, right now, we're going to add in some parentheses that you normally wouldn't add in, but you're going to end up using your calculator on this next part. And what's important to know is that you're doing 3 divided by 2 pi. That means you're 3 divided by 2 and divided by pi. So if you don't put parentheses around this 2 pi when you put it in your calculator will give you a completely wrong answer. Now, you're supposed to be dividing by pi, not multiplying by pi. So without parentheses, your calculator will multiply by pi. So your answer will be, instead of divided by 3, it'll be times 3. So it'll be over 9 times the answer, the value that you should get. So be careful of that. On this problem, I'm going to go ahead and do B first. You kind of saw what happened with part A, or in example 1. So B says, let's find a value of x for which y is equal to 5 again. I think your book always has you do y equals 5, but we could give you any y value. We could say when y is 3, or when y is 2, or when y is negative 4, and you're going to be able to find values of the angle or the argument. In this case, it's x this time because of the radian. You're going to be able to get the answers no matter what. All right, I'm going to use this answer here from part A, that x is equal to 3 over, putting parentheses around my 2 pi, times inverse sine of y plus 2 over 8. But I'm going to plug in a 5 into the y. So that then I've got x is equal to 3 over 2 pi times inverse sine of, add the 5 plus the 2 and you'll get 7 over 8. I don't know about you, but I put my calculator away. My entire kitchen bar is completely packed full of papers and notebooks and books and craziness. Let me grab my calculator. Sorry. Back. Whoopsies. All right. Okay. I don't know about you, but 7 over 8, well, I do know about it. Hopefully you recognize that that is not a value that you have memorized, not by any means. And so you must use your calculator to find that value. To find inverse sine of 7 over 8, you need to make sure, I saw no degree symbols, you need to make sure you're in radian mode. Yeah. And then for radians, we're going to go to 4 decimal places. It's pretty much what we're going to stick to. Is if it's radians, we'll give 4 decimal places, and if it's a degree, then we'll give 2 decimal places. I don't know who decided that. Somebody a long time ago, apparently. I don't know. Okay, so you can put this entire thing into your calculator all at once. So here we go. Turn it on. What mode am I in? I see red, so I'm in radian mode. I'm going to go 3 divided by, put parentheses around it, 2 pi, and the parentheses. Now, that's the only thing that'll be divided. Now they're going to multiply times. You could put times if you want to. Doesn't matter. Inverse sine of 7 divided by 8 and the parenthesis, and then plus 1. And when you hit enter, you get x is about 1.50870, so 5087. Now, that's one value of x where y is 5. Okay, make sure you're in radian mode. Closing those parentheses, super duper important. Okay, then part C says, let's sketch the graph of the original. And see if our answer is reasonable from part B. So the original equation they gave us was y equals -2 plus, but I'm going to move that over to the end so that it'll be 8 times sine of 2 pi over 3 times x minus 1, and then minus 2. So that here's your A, there's your B, there's your C, there's your D. So my A is 8, and B is 2 pi over 3. And C is, remember, it's x minus C, so C is going to be a positive 1, and then D is -2. The period of your graph, I don't see any degree symbols, right? Not only that, but I also see a pi, right? But it's x, so it needs to be radians. It's 2 pi over b, which is 2 pi, divided by 2 pi over 3. Well, that's ugly. So let's, instead of dividing by a fraction, we'll multiply by the reciprocal, so that it's 2 pi times reciprocal of 2 pi over 3 would be 3 over 2 pi. This is like over 1. They're not being quiet. The 2 pi's cancel. Period is 3. Increment length is the period divided by 4. So that'll be a 3 over 4. And you could keep it as fractions. This ends up being a decimal that terminates, so I'm fine with 0.75. Let's make it nice on ourselves. Why not? Okay, keep in mind your A is 8, so that means your normal graph without a D value, you would have went up as high as 8, down to -8, but then I'm going to shift everything down 2 units. Okay, so I need to lower. Draw a horizontal line. Tick marks, cut it in half, cut it in half, cut it in half. Those are pretty nicely spaced out tick marks, if I do say so myself. Remember that C is your very first tick mark, so it's a 1 here, and then you'll add the increment length, add 0.75. So that would be a 1.75, and when you add 0.75 to that, that would give you a 2.5. Adding 0.75 to that would give you 3.25, and adding 0.75 to that would give you 4. Check your period. 4 minus 1. Right minus left would give you 3. Yay. On that, your y-axis goes where x is 0, so I'm going to be to the left of here. Put in my y-axis. I'm going to put in a little x through my y-axis to say don't put a dot there. Don't Don't do it. Don't do it. Not for just the one period, right? And then we can extend it afterwards. But all right, so I need 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And then I need 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to be shifting down 2 more, so I'll go 2 more and get down to -10. Yeah. All right, when we got this shift, it might be nice for us to go ahead and just draw a little line going, here's my new x-axis. That's going to be the middle of my sine graph, right? And you would have went, so if it without the d part, right, I would have graphed a 0 here, and then I would have went up to 8, and then I would come down back to 0, down to -8, and then back up to 0. But then you would have shifted everything down 2 units. I hope you're not hearing my gardeners, but they're very loud. Yeah. So normally would have started here at 0, but we were shifting down to, do a different color. Do this. All right, so first point would be at -2. The next point I would have went all the way up to 8, but then it's a shift down 2, so I'm at 6. The next at 2.5, you would have been at 0, but then we're shifting down 2, so now I'm going to be here. At the next x value, I've got 3.25, which would have been down here at -8, but I'm shifting down 2, so now I'll be at -10. And then I would have come back up to 0, but shifted down. So there's 5 points. It's a little funky, but whatever. There's the 1 period of your sine graph, right? And so this means that this thing would keep on going of, you would be, would keep on going and keep on going, and this guy would keep on going technically, right? So it would keep on going in both directions, but that's your 1 period of this graph. And then let's check out, what about when your y is 5, and see, is our answer reasonable? So here's where, when y is 5, and if I were to draw a horizontal line for when y is 5, yeah, y is 5 at this angle, and here again, and here again, and here again, and here again. Off the page, but yeah, all of these guys have angles where y is 5, and they keep on going, so there's an infinite amount. And we said 1.5087 was our one of the values. And if you take this point right here and you were to go straight down, doesn't that seem reasonable that that right there is 1.5087? And it sure does to me. Yeah. Okay. We'll do more of these tomorrow. Well, not tomorrow. Tomorrow's the weekend. When we come back for the next lesson, it'll be same type of thing, but we'll find more values, not just one. We'll go along and we'll find a whole bunch of them. So, all right. I hope you all are doing well. And stop presenting. Hope you're all doing well. Stay healthy. And come see me in office hours if you're having questions about the material. All right. See you later.